Good morning, Core Math 2 students. This is your Week 6 Lesson 3, and it's all about secant and tangent intersections outside of a circle. So we've looked at chords and their extension, which is a secant line, but there's also another type of line called a tangent line. A tangent line is a line or a segment that intersects a circle at exactly one point. So the tangent line will have to be outside the circle so that it can cross the circle just one time. So it barely touches it or bumps up against it. A tangent line cannot be inside of the circle because it would intersect in one place, but if we extended it, it would certainly intersect somewhere else. So a tangent line cannot be anywhere inside the circle. So let's take a quick look at what this does to our proportions or our equations that we're setting up. So here in circle A, the tangent length squared is equal to the value of A times A plus B on the secant line. So it's kind of similar to what we saw yesterday where we have some products because x squared is obviously x times x. So x is based off of the tangent line or the tangent length, and this could perhaps be extended, but it may just be a segment that ends right here when it touches the circle. So x squared is going to be equal to the segment A times the A plus B. So here in example 1, our job is to find x. So x is the unknown part of the tangent piece. So x squared will be equal to the length 2 from the intersection point to the circle times the product of 2 plus 6. So once again, getting that overall distance from the point outside the circle all the way across the secant line. So 2 plus 6 is 8. So this is 2 times 8, and that's equal to x squared. If we continue doing some simplifying, 2 times 8 is 16, which means x squared is 16. And to finish solving for x, we would apply a square root, and that tells me that x equals 4. Or you can certainly use a calculator if you're not sure about your square roots. So x is positive 4. It can't be the root negative 4 because this is a real world length, and so it has to be a positive amount. So let's try one more example. Here in example 2, this time they gave us the tangent length of 9, and then it's on the secant piece where we don't have the x. Or we don't know the value, so we're finding x there. So our tangent length 9 gets squared, and then we have our short segment 3 times the full sum of the secant, 3 plus x. So if we do some simplifying, 9 squared is 81, and that's equal to 3 times 3 plus x. And then for us to finish solving for x, we would start by dividing by 3 on both sides. 81 divided by 3 is 27, and that's equal to 3 plus x. To finish this off, subtract 3 from both sides. That tells me that x is equal to 24. And that would be our final answer for finding x in this weird secant tangent intersection scenario. So use this information, head on over to Delta Math, and good luck out there.